Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will look at converting decimals and fractions. You probably already know decimals and fractions are just different ways to represent the same number. Any fraction can be written as a decimal, any decimal as a fraction. For example, half and 0.5, exactly the same number. So how do we convert between decimals and fractions? Well, to go from a fraction to a decimal, you use short division, but we're going to start at looking at going from a decimal to a fraction. We use place value. So remember, place value is just about the columns in which you find the numbers. After the decimal point to the right, it goes tenths, hundredths, thousandths, and 10,000ths, and so on. It goes on forever. So how is this going to help us? Well, when we go from a decimal to a fraction, our answer is a fraction. We need a numerator and denominator. It turns out that the place value, whichever column the last number after the decimal point is in, that becomes the denominator. That becomes what goes on the bottom. What goes on the top, the numerator, is just the number without a decimal point. Sometimes you will need to simplify. So if we have something like 0.32, the number furthest to the right is in the hundredths column. So it turns out the denominator is 100. What goes on top? Well, we're just going to write this number without a decimal point, so it's 32. Now, 32 over 100 can be simplified. Top and bottom can be divided by 4. 4 is the highest common factor of 32 and 100. So there we are, 0.32 and 8 over 25, exactly the same number. So what about 0.875? Well, here, the number furthest to the right is in the thousandths column, so 1,000 is the denominator, and we write the number on top without the decimal point. So this is a hard one to simplify. It's hard to know off the top of our head what would be the highest common factor of 875 and 1,000. If you're trying to find the highest common factor of two numbers, it's always a factor of the difference. So the difference between 875 and 1,000 is 125. So their highest common factor will be a factor of 125. It turns out 125 is the highest common factor of these two numbers. 125 goes into 875 7 times. 1,000 divided by 125 is 8. Now, if you don't know what the highest common factor is, you can always just pick any common factor and keep simplifying. So, for example, you can see these two would be divisible by 5. You could divide by 5 and keep simplifying until you get 7 over 8, until we get a fraction where the numerator and denominator have no common factors. All right, what about this last one here? So again, number furthest to the right is in the thousandths column. So we put 1,000 on the bottom, and what goes on top is the number without the decimal point. So can I simplify this? Well, the prime factors of 1,000 are 2 and 5. So any number on top, if it's not divisible by 2 or 5, it's not going to have any common factors with 1,000. So I know I can't simplify this any further. These two numbers do not have any common factors. All right, let's now look at going the other way from fraction to a decimal. So for 3 over 10, if I want to convert that to a decimal, that's really simple because the denominator is a power of 10. This is just saying 3 tenths, so I'm just going to put a 3 in the tenths column. For 9 over 20, I can easily find an equivalent fraction whose denominator is a power of 10. If I times top and bottom by 5, I have 45 over 100, 45 hundredths, and that's just 0.45. So sometimes it's just really easy to go from fractions to decimals. But if I have something like 5 over 16, that's a bit harder. It's not at all obvious what is the lowest power of 10 divisible by 16. 16 doesn't go into 10, 100, or 1,000. It actually goes into 10,000. But without a calculator, it's really hard to know what I would times this by. So what we're going to do for fractions to decimals, the surefire method that will always work is short division. So 5 over 16 is saying how many times does 16 go into 5? And when we're doing these, we'll just write a few zeros. So 16 goes into 5 0 times remainder 5. Now, when you're using short division algorithm, really important, decimal point goes above decimal point. So how many times does 16 go into 50? Well, it goes 3 times remainder 2. How many times does 16 go into 20? Well, it goes 1 remainder 4. How many times does 16 go into 40? Well, it goes 2 remainder 8. How many times does 16 go into 80? It goes 5 times. Now, because there's no remainder, we stop there. So 5 over 16 and 0.3125 are exactly the same number. So let's try 2 over 9. So there's a problem here. If I wanted to make this an equivalent fraction whose denominator was a power of 10, I would have no luck. There's no way I can do that. 9 doesn't go into 10, doesn't go into 100, doesn't go into 1,000, 10,000, a million. There is no power of 10 divisible by 9. So I'm going to have to use the short division algorithm. So this is saying 2 divided by 9 is saying how many times does 9 go into 2? And we'll just write some zeros there. So 9 goes into 2, 0, remainder 2, decimal point above decimal point. How many times does 9 go into 20? Well, it goes 2, remainder 2. How many times does 9 go into 20? Well, it goes 2, remainder 2. How many times does 9 go into 20? Well, it's 2, remainder 2. You can probably see what's happening here. For this one, 2 over 9, this division is just going to go forever and ever and ever. So the way that we write this, 2 over 9 is equal to 0.2 recurring. The 2's go on forever and ever. So all of these ones up here, they are what we call terminating decimals. Terminating means ending. So all of these numbers up here had decimal places that ended. After a certain number of places after the decimal point, the number stopped. This one, on the other hand, the 2 goes on forever and ever. The numbers after the decimal point do not stop. We call those ones recurring. So recurring decimals go forever and ever. It turns out 1 over 27 has a recurring decimal as well. So that's saying how many times does 27 go into 1? And I'm just going to write a few zeros here. So even though 27 is a big number, we're going to do this the exact same way. So 27 goes into 1 0 times, remainder 1, decimal point above decimal point. 27 goes into 10, 0, remainder 10. So now this is 27 into 100. Well, it goes 3 times remainder 19. So now we say how many times does 27 go into 190? So if you keep adding up 27, you'll see it goes 7 times remainder 1. So how many times does 27 go into 10? 0, remainder 10. How many times does 27 go into 100? 3, remainder 19. How many times does 27 go into 190? 7, remainder 1. And then 27 goes into 10, 0, remainder 10, and so on. What you're going to see is this pattern repeats. 1 over 27 is 0.037037, The pattern of 0, then a 3, then a 7 repeats infinitely many times. It goes on forever. So it turns out 1 over 27, we write it like this. We put a dot over the first and the last, and that means that anything within these 2 dots repeats infinitely many times. We don't need to put a dot over every single digit that is repeated, just the first and last number in the pattern. All right, let's try 4 over 15, which also has a recurring decimal. So that's saying how many times does 15 go into 4? And we'll write some zeros there as well. So 15 goes into 4, 0 times remainder 4, decimal point above decimal point. 15 goes into 42, remainder 10. 15 goes into 100, 6, remainder 10. 15 goes into 100, 6, remainder 10. So how many times does 15 go into 100? Once again, it's 6, remainder 10. You can see, once again, unlike these decimals up here that stopped, this is just going to go forever and ever. It's 0.2, and then the 6's go forever. So that's what these 3 dots mean, by the way. They mean it goes on forever in that pattern. So the way that we write 4 over 15 it's 0.2, but we only put the dot above the 6 because only the 6 is repeated, the 2 is not repeated. So when we write it with these dots, we call that exact decimal form. So when do terminating decimals arise and when do recurring decimals arise? Well, it's not just if the denominator's even, it's terminating, and if it's odd, it's recurring. It's all about, can the denominator go into a power of 10 evenly? 10 goes into 10, 20 goes into 100, 16, it turns out, goes into 10,000. So when the denominator can go evenly into a power of 10, you have a terminating decimal. You have a decimal that ends after a certain number of digits after the decimal point. But when the denominator is a number like 9, 27, or 15, when it is a number that cannot go into a power of 10, the decimal goes forever and is recurring. It goes on forever and ever, but there is a pattern to it. So as an example, I know without even calculating it that 1 over 12 will be a recurring decimal because 12 cannot go into any power of 10. And I know that something like 3 over 25, that will be a terminating decimal because 25 goes into 100. It goes into a power of 10 evenly. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.